These are the... Ooh. Somebody touch my machine. Don't touch my machine. Okay, is that better? Can't touch these things. Okay. I don't know. I wasn't in here. Okay. If you have, this is the rules for derivatives, the shortcuts. And if you have a constant function, then what's the derivative of that? It says now, this is a horizontal line. What is the derivative? It is the slope of the tangent line. So somebody said 0. So what if you have y equals mx? What's that slope? Where's your hand up?
Right here.
It's m. So now, looking at patterns here, if my function's x squared, then what's its derivative? 2x. If the function's x cubed, it's 3x squared. If it's x to the fourth, it's 4x cubed. So what will x to the fifth be?
4, 5x.
Okay. And if we have time, I got to check the calendar. I thought we had 3 days in this. I can prove to you why it is what it is. Right now, you're just going to have to believe that that's true. You've seen examples of that. So what if it's x to the n? And, okay, make sure you always subtract 1. Now, if you want the derivative of a constant, so I'm going to take the derivative operator times k x. I can pull that constant through the operator, just like we do with limits. So it's the constant times the derivative with respect to x of x. What's the slope of 1x? No. What's the slope of x? It's 1. Think it's just slope, so this ends up being just the k. Okay? Now, things are still fairly easy. If I do the derivative of the sum, or difference, it doesn't matter, you could take the derivative of each one of those separately. So h prime of x is equal to g prime of x plus or minus f prime of x. So it distributes. So that's not too bad. Unfortunately, it doesn't work for multiplication. So we have a little rule. It's called the product rule. That's the result after you multiply. And so what you do is you take the first function times the derivative of the second, so it's f prime of x, plus the second one times the derivative of the first one. That's all there is. Now, I would like to make it g prime times f prime, but it's not true. And proving the product rule is tricky. And I'll look it up and see how hard it is, but I think it's pretty hard. I think I have it right. By the way, what happens if I reverse the order here? Does it change anything? No. No problem. So you don't have to worry about order here. But on the division one, which is called the quotient rule, we do have to worry about it. Okay, so I'm going to do it 2 ways, the way I do it, and then there's a little rhyme to help you remember. Here's how I do it. I start down in the denominator. I go up to the numerator, come back down. So it's the denominator, okay guys, times the derivative of the numerator. So that's f prime of x. And then it's minus, it's not plus, but you know, multiplication is going to give me a plus. Division will give me a subtraction. And it's what? F of x times g prime of x. Whoops, what is that in red? But there's a little more. It's all over the square of the denominator. And we never square it out. That's a minus. So it's all of that. Like I said, proving it's tricky. Well, here's the way we can do it with a little rhyme. Okay, so it's a fraction. It's high over low. So the derivative of that, whoops, is equal to, well, it's the denominator, times the derivative of the numerator, I guess I'll write it like that, minus the numerator times the derivative of the denominator over the square of the denominator. So it's low d high minus high d low over the square of low we go. So it's the low one times the derivative of the high one minus the high one times the derivative of the low one. Over the square of low we go. Low d high minus high d low over the square of low we go.
Over the square of low.
Over the square of low we go.
Yeah.
But, yeah, we'll do them. Oh, yeah, we'll do them. I always just do the denominator times the derivative of the numerator. But does it matter on the order here? Does the order matter? Yes. So where do the mistakes happen? Wrong order. Okay, ready? That was it. We'll do some problems. On the back, there's a whole bunch of problems. It's just a rhyme. The low is the low one times the derivative of the upper one, the high one. So it's just a rhyme. Low d high minus high d low. Over the square of low we go. That's all. What? Yeah. The low one's the denominator, high one's the numerator. Okay, so turn it over. Whoops, sorry. I just wanted to check here. Oh no, we do only have 2 days on this. That's too bad. Okay, try these. First one shouldn't be too terrible. What's the first one? Now remember, you just ignore the constants. A little more. So it's 3, 5x to the what? 4. Now, Frank, can you just go right to the answer on that?
I can go straight to.
Do you have to show that in between step? No. So what about the next one? Okay. What's f prime of x? Now, you guys, let's just get to the answer on this. You multiplied 8 times the negative 2, negative 16. Now you go down, x to the 7. I don't want to use the definition of the derivative on that. I'd have to expand x plus h to the 8th. Not fun. Let's ignore the fraction for right now, and then do the derivative of this one. Now be careful. It's negative 9x, go down, negative 10. Is it easy to come up with the wrong way? And we don't really care about simplifying, but I want to simplify this because it bothers me to leave it like that. But it's not that hard. 3 goes in once, goes in 3 times. So I get negative 16x to the 7th, and this will give me what? A negative times a negative is a positive 6x to the negative 10. Circle it because that 1's in the way there. Now there's 2 ways to do the next problem. I can use the product rule, or I can multiply it out. And we'll probably do it both ways, just so we can see that. So the product rule says it's 3x plus 5 times the derivative of the 2x minus 7. What's the slope of 2x minus 7? Think geometrically. It's just 2. Because the slope of 7 is 0. Plus, and then it's 2x minus 7 times the derivative of 3x plus 5. Product rule. This is f times g. Multiplication. And then, so it's 2x minus 7 times the derivative of 3x plus 5, which is 3. We're going to do this 2 ways so that you actually believe the product rule. Well, this isn't hard to simplify. Well, hang on. Let's simplify this out. It's a 6x plus 10 plus 6x minus 21. Oh, we just got this. So it's 12x minus 11. Now, could I multiply that out first?
Derivative that's L.
Didn't ask for a second derivative. This is only the first derivative. This is f. This is f prime. Don't keep going. This is f prime. You might. Let's multiply this out. What does that multiply out to give you? Now, I have to write it down. You should be done multiplying it out before I get done writing it down.
6x squared.
Prime of x?
This is f. 6x squared minus 11x minus 35. Okay, now let's do the derivative of that. This is the derivative I've been doing. This is the derivative right here. And then I multiplied it out and combined similar terms. Just multiply it. I'm doing this a different way. I expanded this. What's the derivative of 6x squared? 12x minus 11. So those of you who want to say it's the derivative of the first times the derivative of the second, can't be. Has to be the same no matter how you do it. So it's not justification, but at least it's an illustration. Take the derivative. This is f. This is f prime.
How'd you get the...
Right. What's the slope of 35? 0, right? It's horizontal line. What was your question? Other question?
Just look at that, you got the 12x minus 11 and just straight.
What's the derivative of this? 12x. What's the slope of this one? Remember, you can take the derivative of each of the little parts. Happier now?
Yeah, I just heard it 12x. 12x.
Let's do this two ways. You want to expand this one first or do the product rule? You want to do the product rule? Okay, so f is equal to this. Now, some of you may be saying, I've got a power rule here. Why can't I do that? Here's the problem, you guys. Here's the problem. This is a composite function, and I haven't taught you how to do composite functions yet. What if there's a function inside of another one? So we're going to have to use the product rule. So what's f prime is equal to the first one times the derivative of the second. What's the derivative of the second one? Negative 5. Is that okay, Grant?
Yeah.
Just asking for the slope. Plus, and then it's the second one times the derivative of the first, which is still negative 5. So you have two of those, right? So if I wanted to add that up, I get two of those, minus 5x plus 8 times negative 5. What's 2 times negative 5? Let's do the easy math. That's negative 10. So negative 10 times this, which I wouldn't have to write, but it's 50x, right? Minus 80. Okay, let's multiply this out. Yes. Question? What? There are two of these terms. I just add them up. You can distribute. You'll get, because this one is identical to this one, so there's two of them. Okay, guys, let's multiply that out. Did I do it right? If I expand that, what's that give me? Grant?
What?
You pay attention, it's a lot easier. What's minus 5x squared? 25x squared. Now you have 40, but you have it twice. Plus, okay, what's the derivative of that? What's the derivative of 25x squared? 50x. What's the derivative of minus 80x? Minus 80. So, even though I haven't proved it, I should be convincing you that you can't just take the derivative of the two functions and multiply them together. I wish. No. But whichever way you'd like. Okay, guys, ready? Oh, is he cheating? Yes, your calculator will do that.
Ow.
It's called, under calculus, it's called derivatives, first one on the CAS. Okay. Let's do this one. Now, I'm not going to do this I don't want to multiply that out. Do you? So let's use the product rule. So it's x to the 8th minus x plus 3x squared. I just recopy that. And then we'll do it times the derivative of the second function. Should be doing it with me. Well, we're not going to simplify because I'll worry about simplifying the result of this in April of next spring because you're not going to remember it for all that long and you'll just have to be able to do it on multiple choice. I can think of one problem where I've seen it this nasty. What's the derivative of this?
Negative 12x.
To the third. Is that okay? Okay, because I'm writing so big, I'm just going to continue it here. Then I take this one and I leave it alone. X to the 4th plus 2, and then I do the derivative of the first one. I could have reversed the order, it doesn't matter. What's the derivative of x to the 8th? Good. What's the derivative of minus x? Negative 1. Is that okay? What's the slope of negative x? Yeah. I'm just continuing. I don't have enough space.
It's supposed to be just plus, but it's
Okay, what I'm going to do is this. Make you happier. Whoops, that was the wrong thing to grab. I'm not done here.
That's what it's supposed.
That's what it's supposed to be. Okay, what else do I need? Plus, and the derivative of that is 6x. Whoa, why is that not working? There we go. Not that one, this one. There. Now I got it to fit. Okay, do we care about simplifying that at this point? No. Now on the exam, you guys, on the exam you will have to simplify it. Actually, you'll be factoring it. But right now my goal is just to make sure you know the product and the quotient rule. So I don't care about the simplifying. So this one, I don't want to divide that particularly. So we're going to do the quotient rule. So you start with a low. Yes, this is the division rule. Times, guys, times, okay, it's low d high, so I need the derivative of the high one. 8x to the, we just did it, 7 plus 6x, right? Low d high, then it's what? Minus high, that's x to the 8th minus x plus 3x squared times the derivative of the low, which is negative 12x cubed. Sorry, not enough space. All over the square of low we go. Am I going to multiply this out? And if you multiply it out wrong on the exam, they'll take the point away. So don't multiply it out. It's a waste of your time. That's it. Does it matter the order in which I do this? Yes. On the multiple choice, you'd have to multiply it out, but they won't multiply it. You're going to factor it, but I'll deal with it in April. Nothing that complicated, no. No, I won't test you on this. Okay, Adam, I could test you on simpler simplifications, but not on this one, okay? This we will worry about in the spring. We'll just prepare for the test. Now, there's two ways to do this one. Should we practice the quotient rule, but there's an easier way? No? I could do product rule, but that's hard too. Let's do it the hard way. Okay, so it's x squared times the derivative of the numerator. It's low d high. So the derivative of 3x to the 9th. 3 times 9 is 27. X to the what? 8th. Minus 2x plus 5 Okay, then it's what sign? Minus. Now I'm going to leave the numerator alone. It's high to low. And then I need times the derivative of the denominator. It's just a formula. What's the derivative of the denominator? Over the square of low we go. I know another way to say it. That's why I keep messing up. Yes, but you don't have to. And you can't probably get that wrong either, because if you add them or you multiply them, doesn't matter. Okay, I think there's an easier way to do this. Okay, guys, simplifying that is not that hard, but it's not that much fun either. Why don't we divide this out first? Can't I divide that? As long as I divide x squared into every term here, there's a variety of ways of looking at it. I just like to divide it myself. Or you could write it this way. F of x is equal to 1 over x squared. And you could use the product rule here now if you wanted to, but then you have to figure out what to do with that. This is the same thing. That's the same as that. And if I distribute the x squared through this, right? What do you do with exponents when you're dividing? You subtract them, right? So this is going to be 3x to the what? 9 take away 2 is 7. We are going to get a negative 1, though. What happens when I do 1 over x squared times x squared? Minus 1. And then what happens when I get, this is why I said you might find this harder, but I have to do 5x over x squared. That's 5 over what? X. Or 5x to the negative 1. Okay, Ricardo. Now, I can do this. I want to use the power rule, and I don't know what to do with 5 over x unless I use the quotient rule, and I don't want to do that. Power rule is easier. So now when I do f prime, the answer is going to be quick. What's the derivative? Which is 21. That's 0. Minus 5. Now careful. Negative 2. You go down. Decrease. Okay, the question is, can we do it the quotient rule? Yes, you may, but I'm probably going to make you simplify it. And to get from that line down to that line is not going to be so easy. Now, one last example, which I should have written in here. What if I have the square root of x? What about the derivative of that? All I know is this power rule. We will learn more. Guess what? You can do this with fractions. So f prime of x is equal to 1/2. And then x, you subtract 1. What's 1/2 take away 1? That's the answer. If you don't like that, it looks like this. Now, if you did the square root of x before, it wasn't so much fun. Remember, you had to rationalize and all that stuff when you use the definition? Now, what you're going to do on the exam is recognize that this is a derivative and say, oh, okay, it's just the derivative of the square root of x. I know how to do that. That's what you have to know with the definition. I have seen it in the free response, but not for a long, long time. That doesn't mean it can't happen. It's 1/2 minus 1. Because the rule is n x to the n minus 1. Okay, that's it. Tomorrow we have some activities we're going to do. And we keep moving on, and we're going to be almost ready for a test. How to get what?
Negative 1 minus 1. Whenever you take the exponent.
You subtract 1. I know you want to go up and make it 0, don't you?
Makes sense.
We all do. Even I do after years. Okay, we got to get spread out. We have a homework quiz. No. All right.